problem 2. Okay, problem 2. We need to calculate the survival function and probability density function for Tx using Gompertz law of mortality. So we have to remember the formula for Gompertz law. Last lecture we have discussed and got the point that we use BC times T. This is the Gompertz law. So let's input the corresponding values for BC and X and then try to express the survival probability and the probability density function. So we need to calculate both S and mu. And the probability function is f small. So problem 2. For x equals 20, we got the force of mortality. The force of mortality, that means mu 20 plus t equals to bc to the power of 20 plus t. This 20, so it is just x, so we have several values, x equals 20, x equals 50, x equals 80. Let's derive the formula for survival function. The survival function as 20 t equals to exponent for fraction of b log c, and also generally it will be too small, so I'll not put it in the power, so that will be the exponent of this. So minus minus b over log c times c to the power of 20 times c to the power of t minus 1. So this will be our formula for survival function. And the probability density function will be found from the mu. When we know mu and we know the survival function, then our f will be f, probability density, is just the multiplication. So the product of mu 20 plus t and s 20 t. So this is the product. We know what s is, and mu 20 plus t should be bc 20 plus t, because we have just written it. That's it. So we just need to multiply this times this. So the formula written here. Alright, now let's put some numbers in our code, and let's plot the survival functions for these ages x equals 20, 50 and 80, and also corresponding probability density functions to illustrate some general points about lifetime distributions. Alright, we need to create our R. over here and start with the values. b c equals 1/7 as given in our task. Then let's x equals 20, and let's s will be the exponent of -1 times b over log c, times c to the power of x times c to the power of t minus 1. Okay, this will be bcxs. C to the power of t non-numeric. Why c to the power of t non-numeric? Log c. Yeah, t is not given. So t, let's say that t is some value. Let it be also 20. So s will be some kind of a value over here. Then let's put mu. It will be b times c to the power of x plus t times exponent -1 times b over log c times c to the power of x times c to the power of t minus 1. This is mu. Alright, when we have both these, f will be just s times mu. This is our probability density function. And let's check the formula, which is written here. bc to the power 20 plus t times exponent. Yeah, I think everything should be okay. Extra y extra log c over here. So our mu, our s and f. Okay, so now everything is correct. Now what I suppose that we have to write down some kind of sequence for values of t, and instead of t we put sequence, let's say from 1 to 100. Recalculate our s, mu and f, and we will be able to plot the values of probability density functions and for survival functions. Let's say that we plot the values of s, and this will be the graph for values. We also can change to 0, and this is the graph from 0 to 100 when x equals 20. If we change x equals to 50, we recalculate that and we got another type of graph. And if we move to 80, our graph will eventually move left. The same kind of values can be drawn if we plot f instead of s, and we also change, and this is the density function when age equals to 50 and 20. So this is the density function when x equals to 20. Okay. Alright, next we have to plot each line which have been built before on the same plot, and then we have to comment the features of the graphs. So this kind of plotting is the standard plotting using by R, and we will change that to ggplot. So we need to install packages, which is called the ggplot2, and we also need to install packages which are called reshape2. So both packages needs to be installed, and then we use the library where we select the reshape2 and select ggplot2. Next we need to create the data frame, and because in order to plot something with ggplot2 we need to create the data should be inside the data frame. And in order to create the data frame, first we need to fill 3 columns with S and with F. So in the first place we create arrays. These will be 2-dimensional arrays. The dimension of the number of rows is 100 for years, and 3 for 3 types of ages, for our 20, 50 and 80. The same goes to date F. Okay, these are 2 empty arrays. Now they have been created, and date F and date S, they are, let me remove redundant versions, and that S. Okay, so we can see that also. Let's remove redundant that. There are 2 arrays. The first one and the second one is the same. It just contain zeros inside. So our initial state will be x equals 20, and then we use the cycle. The first cycle will be for I in 1 to 3, and the second cycle will be for t in 1 to 100. So for the first cycle we will move through columns, and the second cycle will move for 4 rows. Next we use these 3 lines to calculate what we need. So here the result of this calculation will be written to that S T Y. The same applied here, and the result that F T Y will be calculated here. So first cycle will start when x equals to 20. Then we need to fill 100 rows of our array, and then we need to change the value of x. So on the first run it will be 20, on the second run 50, on the third 80. Let's run this. Now we have the values for that F and that S, which are filled in our arrays. Now we need to create 2 data frames. The first one will be called the df, and we apply the command data frame to our dat s, and then we have to change the shape. So now df is look like this: 3 columns and 100 rows. I need to change it to 1 column with 300 rows, and to change this we use the package reshape2, inside which there is a function which is called melt df. Then we apply id vars. There will be some kind of an index value. Index value should be created by us, and the variable name is called series. So series is just what we use to name our variables. Let it be series. And index is something that we need to create. So df index will be the sequence from 1 to 100. So after we apply this function df index, there is the column which appeared, the fourth column in this array from 1 to 100, and our ID values will be the indexed values. So we apply this function df, and we see that df now changed to this kind of shape. So it contains 300 values inside. Now when everything is done, we complete our calculations with ggplot. We use df AES. AES is aesthetics for our values, and the aesthetics contains of x and y variables. So x variable is index and y variable is value. When we define the aesthetics, we need to select that the type of plot will be line, geom line, and here we will apply the color scheme. Color will be our series. Let's try and plot this. Now we can see that we have the name of the variable index and value. We have to change that. We also need to put some name, some title for this graph, and change x1, x2 and x3 for ages. So let's apply these transformations. We add labs where x equals to h and y equals to probability. When we plot it, so we have changed h and probability. Next we apply the name of our graph with the command title, and title will be survival functions. That's it. Next we add custom legend here. In order to add custom legends, there might be several options. I just use the scale color manual option for that. Scale color manual. Inside we need to specify two variables, one of which is called labels and the other one is called values. So labels will be vector, and inside this vector we specify three names. For x1, let it be h equal 20, then 50, and then 80. So these are labels, but we also need to specify values, and values should be also vector for three types of colors. We can choose whatever colors we wish, so I just stick with the same colors, which green and blue should be like this, green here and blue here. And I think that's it for our graph.